Hello, everyone. It's still morning time, and I was going to say good afternoon. Yeah, but good morning. So we're about to just kick off session number 2. So I'm just going to run through the agenda really quick for session 2, and then I'm going to hand over to Michael from Dublin Fire Brigade to kick off his presentation. So that's what's next. Michael from Dublin Fire Brigade is speaking about using FME server with webhooks for Tableau reporting. Then Hrvoje from IMGS will step in and he'll talk about building enterprise. Oh, I haven't updated this slide. It's actually CAD validation using FME server apps. And then we'll have Ciara Beddy from OSI presenting on Prime 2 to product, automated map production. Myself and Ardi from Safe Software will talk about scaling for the enterprise. And then Robyn from National Broadband Ireland will also talk about their use of FME. And then we'll close out with Ciaran, Kirk talking about data capture with BI integration, and a bit of a wrap up from myself, Tanya and Gavin, which is brilliant. So Michael, again, thank you very much from your extremely busy schedule. So I appreciate you taking the time to present. Yeah, I'll hand over to yourself.
No problem. Thanks, Garrett. I'll just get my screen up. Is that presenting now?
Oh, it's not. Michael, right. No. Sorry, Garrett, you're on mute.
It should be it now.
Yes, I can see it now, Michael. There we go. Brilliant.
Perfect. And thanks for having me on, and thanks for a great presentation so far. Really interested to hear Don Murray, and I think I'm going to start calling myself a data artisan from now on. I like that that name. So I suppose this is just to talk a little bit about how we use FME in Dublin Fire Brigade. I suppose there's a very flexible, extensible, tool to fill loads of gaps. It's really useful. In DFB, we I suppose in terms of our existing infrastructure, we have a Oracle Business Intelligence Enterprise Edition platform for BI, which has been there since kind of the mid-2000s. And while there's lots of dashboards implemented in it, it's probably more suited to financial or enterprise reporting. It's very locked down. It's quite very structured. And it was a tool. It's probably one of the only BI tools available when it was implemented. But there's a high learning curve for users and developers. So to a certain extent, the dashboards have become quite stale on it. What tends to happen now is the BI the users tend to just go into the BI, do a custom query, and extract data into Excel and do their own reporting, which obviously results in several issues in terms of data quality and governance. So I suppose Tableau is the BI of choice in Dublin City Council at the moment. There's certainly better functionality. You've got spatial views, temporal views. It's very interactive. It's very well supported for developers and users, and there's a rapid turnaround for visualizations as well. So I suppose one thing that it's not good at is for reporting. I suppose it's kind of one of the main, one of the most commonly used functions within the Oracle Business Intelligence is trying to get a custom report or an incident log sheet for a particular incident. So you'll search on an incident, apply the filter, click the ISR number, the unique ID of the institute, so you can see some kind of summary data there for that record. But then to pull down detailed information about it, so what type of fire it was, what appliances were in attendance, what their timestamps were, and then any comments. So within our dispatch system, there'll be a lot of comments entered on the dispatch system that kind of give the context of the incident, etc. So that workflow, in order to kind of transition to Tableau, we'd need to implement that workflow to be able to give us kind of a custom report. I suppose I struggle to kind of build that within Tableau. It's not really good at a very mixed type of like report sheet. so I suppose what the decision was made then to build an in-depth report in Tableau using FME Webhooks. So again, just the video there is showing the kind of information we can get. So again, you have the incident row view with a duration, in minutes of the incident. And then you can also kind of hover over each appliance and see what their timestamps were as well. And then was driving the incident report sheet. This is where the FME webhook comes in, and you have a incident report sheet for this incident. So you can see all the details of the incident. You can see average speeds, travel time, and average speeds for the appliances traveling to the incident. And then at the bottom, you have a kind of an accordion type HTML element that shows the comments for that incident. So all the information from the previous report available through a Tableau interface using FME webhooks. So I suppose just to mention, it's I'm just going back there. The FME webhooks, the flexibility of the HTML reporting engine. You can put anything you can do on the web. You can essentially put into your HTML report, such as interactive web mapping. One nice implementation I've put in is a Google Street View widget. So say you have the location of the incident, you can show the street view of that and gives a lot more context of it. I suppose I was trying to run this just recently, or just get this up and running for today. But the thing with Google is their APIs creep a little bit, and if you're not keeping up to date with them, they can kind of break your workflow. So just unavailable as today. And then you can build expandable and interactive tables. So anything with HTML or CSS is available through that. And just to talk through the webhook itself. So this is the workflow that was used for it. So you're using just the incident number as the FME parameter. So the ISR number is the key element here, and that's shown in the Tableau report on the left hand side. So that's basically set as a parameter that goes into this workspace, and these three workspaces on the left hand, or these three readers on the left hand side, use that ISR to pull a series of rows or one row from our database, and then it's fed through that workflow. And you can see here where the actual FME pulls that parameter, the query ISR, and uses it in the query to load the data using SQL Creator transformers. And then I suppose just the intermediate steps then are just kind of data filtering and joining steps. And then in this area here is where the HTML itself is actually built. HTML report generators and layers build a web page. HTML output is the last step, and then that's published to FME server to configure the webhook. So then once you move to FME server, it can be a little bit confusing. I think Garrett, you helped me on this one, just where to actually find the webhook building. It's actually not an automation. It's actually accessed through the workspace interface itself. So you can see here that I'll just pause the video. You click through the first webhook dialog, and you need to basically get through to the second page. And this for Tableau, it's the authorization of query string. You're basically pasting this into a dialog within Tableau, as you'll see in a minute. Again, just in terms of the logistics going on in the background, you need to ensure that there's network access between all three components. So that there's access from Tableau server, if you're running that in your organization, to FME server, and then if that FME server has access to the database servers. And then I'm pretty sure that you need to make sure that the tokens are configured to allow access for the workspace to the data sources as well. So that's something you may need to make sure of too. So you can see here, this is the string that I've copied from the webhook interface. You can see it there. You can see that the parameter that I've set, so df20 1 2 3 4 5 6. So this is the default value for the parameter. That kind of serves as a placeholder for what you're going to use from Tableau to drive that. And then this is your token that you've pulled from, that's been generated one time in FME server. So again, you're going to work the workspace actions, and you are going to set up workspace action. So it's open a web page action. So here we are, and this is where you just replace the default parameter string that you've copied across with the variable name from Tableau that's going to be used to drive the automation. So again, you can test that to see if the link works, with the test link button, and that will give you the end result. That's a very quick quick run through that. I suppose what I might do now is maybe do a live demonstration of the actual the webhook working. So you just have to bear with me for a second.
Some really, really useful insights there so far, Michael, which is amazing.
So here's our this is the dashboard itself. So as I said, you have the hover over this and you can see the kind of interactive tooltips showing the timestamps for particular vehicles that are appliances that attended the incident. So then clicking on the incident, you have this, basically how you access that report is it's a URL that's accessed through clicking on the ISR number. So when I click on that, then it's going to basically run that FME report. And as you can see, it's almost instant, so really, really quick. So very, very, very effortless response. So you have this instant report sheet for this incident, an interactive map, which which is very useful. You wouldn't have got that through OBI from Oracle Business Intelligence. Again, looking at so you can insert some notes, just describe some metadata on your kind of your visualization, maybe just things to be aware of. And then across this table, then you have the attendance, the vehicles of attendance. So what was the distance from their home station to the incident? And then because you have the mobilization time, it's like you'll be able to get an average speed as well, or the average speed as well for that. So this is 43 kilometers per hour was the average speed for this appliance attending. And then this accordion effect here. So again, you don't want to overload the data. The comments are just available if needed for that incident. So that's it basically. So I'm going to give you back.
Brilliant. Thanks, Michael. I have two questions myself. So when you mention appliance, does that just relate to, and I suppose probably for the people that wouldn't be probably too familiar, is that just a fire engine and an ambulance, or does that go across, like does every fire engine and every ambulance have its own unique identifier under appliance, or is there other types of appliances?
Yeah, as you saw in the, sorry, I don't know if you noticed there, I should have pointed it out, as when you saw the appliances, as we call them, or the vehicles, the row of vehicles that attended an incident, they're color coded by their type. I just have that in Tableau. So every appliance that attends an incident is recorded. So all those actions are recorded in our dispatch system. So we can access them through our the database tables that are built from that dispatch as such.
No, brilliant. And my other question was around travel time. So again, it's obviously a key metrics throughout everything. What does that come around to? Is it so when you are planning for future events, you know that on average it takes to get to that distance for that type of incidents this particular amount of time, or is there maybe a threshold that you need to meet as an organization? Or
yeah, I mean, we obviously it's recorded on timestamps, and those are kind of harvested from our radio telemetry. So when the officer arrives at a scene, he keys in that he's there. So that's the timestamp that goes back to dispatch and is recorded as they're in attendance. Yeah, obviously we have kind of response time KPIs to meet, national KPIs, but it's also useful to kind of see within. We don't have great telemetry off our vehicles. We're moving towards a national computer-aided dispatch system, which should improve that. But we're very in the rough. We want to try and get average response speeds for a certain location, so we use it that way. You're on mute, I think.
Yes, so no, thanks for that, Mike. I really appreciate you taking the time, and I know it's something that you've been actively working on for some time on FME across the Dublin Fire Brigade as well. So I really would appreciate you taking the time to come in and present to us today. I'm going to hand over to Hrvoje next. Hrvoje, if you want to share your screen.
Yeah, no problem.
And again, if anybody thinks of any questions later on, don't be afraid to drop them into the chat, and then we can reach out directly. Or again, most of the presenters have shared their email address, so feel free to jump out to them directly. Or again, you can come to ourselves, and we'll gather up the questions and send them on to them, and then respond to you guys. Hrvoje, I'll hand over to you.
No problem. I'll start. Just to see if this is working. My name is Hrvoje Vukasinovic. I've started with IMGS at the start of this year. And today I will be talking about how to translate CAD drawing like this into the attribute-rich GIS information like this. In order to make it possible, it is crucial to establish some business rules on how CAD drawings are made. These business rules can be as simple as a couple of bullet points or 100 pages long standard document, depending on the task. Too many rules can make process more complicated to build and maintain. Just a few rules can make can leave a lot of gray area. I believe it's important to achieve the balance between the two. Based on my own experience, I would like to point out three main challenges in CAD to GIS conversion. First is definitely map projection. Second, geometric consistency, or should I better say inconsistency, and attributes. How attributes will be assigned to geometry objects since they are not together in CAD, they are separated objects. Regarding map projection, we all know that CAD is not great with handling map projections, at least not standard AutoCAD. I believe the similar situation is with other CAD software. But even bigger issue are people that are not aware of map projections. Many drawings are created in local grids, scaled 1000 times to get millimeters. And even if they are created in certain map projection, it's sometimes difficult to figure out which one it is. I believe first you should specify desired map projection and communicate that with drawing makers. Is it ITM, ING, or any other? It just has to be specified and communicated. In some cases, bounding box can be used to validate if data is really submitted in that map projection. For example, in case of ITM, Irish Transverse Mercator map projection, this approach can be used to identify if if objects are in local grid or scaled 1000 times. Even though specifying map projection automatically says which units should be used, meters or any other unit, there is no harm to specify it once again. I had a couple of situations where people were claiming that something is submitted in ITM, but it was actually scaled 1000 times. Which is not an issue if it's scaled around the origin point. You can retrieve these coordinates by scaling back around that origin 00 point. but it is a huge issue if some random point was used for scaling, and there is no way to retrieve these coordinates unless someone tell us which point was used. Regarding geometry, no proper line snapping can cause topology issues like closing out polygons or creation network topology. CAD software supports many formats, lines, splines, hatches, etc. Inconsistency of using these can also create issues. Overlapping lines, they are tricky to maintain. So in my opinion, it's better to avoid them if possible. Most dangerous thing about them is if lines supposed to overlap, but they're actually slightly diverging or crossing. This can confuse the script and create a lot of polygons, a lot of small polygons or gaps around the boundary, which is not what we want, definitely. I believe solution would be to specify snapping as a mandatory, specifying allowed CAD object types like line, hatch, or similar. Introduce in case of overlap, it would be good to introduce, if we want to avoid them, it would be good to introduce the layers priority. For example, if land registry parcel boundary coinciding with building outline, one should have priority over the other, and we should have only one line, not the both. Real world examples are efficient way of explaining these rules, and for example, showing them beside each other what is wrong, what is correct, would be efficient way of explaining people what you expect rather than writing text. Regarding attributes, there are multiple ways how to assign them to geometry objects. There are two most common ones are through the layer name and using text in the drawing. Inconsistent layer naming can make that process difficult. If we have text not strategically located, scattered around the drawing, it could make it unusable almost. First step to solution would be to specify layer names, create a layer naming convention. That layer can be used to populate one attribute in GIS, or we can make a process a little bit more robust and use delimiters in the layer names. This way we will be able to populate more than one attribute. For example, in this example on the slide, layer name is split in 4 different parts, so we can use these 4 different strings to populate 4 different attributes. Regarding text, placing it on the strategic location can make use of it. Like we can, if we want to assign text to line, we can snap it on that line. Or if you want to assign text to polygon, we can place it inside of polygon and use a spatial intersection for it. Multiple text can be used at the same time. We can use attribute blocks. In my opinion, attribute blocks are generally easier to maintain as long as template blocks are created and provided to drawing makers. Also, geometry can bring some attributes itself, like line color or text rotation or something similar. So we can bring them to GIS as attributes as well. I would like to present an exercise. There is a couple of rules that I have established for the purpose of this exercise. So layer naming should follow this example. Information must be submitted in ITM map projection. Features must follow the list of acceptable formats. In this example, line or polyline, it doesn't matter. arc is acceptable and text objects. Line overlaps are not allowed. Parcel layer has priority over the building layer. And some topology rules. Incomplete polygons are not allowed, and each polygon must have one centroid, one text object, and only one, not less or not more. Here is the example of one CAD file that I've created. On the left-hand side, you can see a list of layer names. Ones starting with 100 are existing layers, and ones starting with 101 are new layers. And then there is the specification what that layer is. There is also one intentionally wrong layer name, which will be pointed in validation process later on. On the right-hand side, there is a drawing itself. There are two lines that you can spot that they don't belong there for sure. The second one is probably even outside of the ITM range. If we zoom into the main area, you will be able to see land registry parcels. Each parcel should contain one text, one number, and same story is with the buildings. And you can notice that there is no overlap of parcel and building line. There are three numbers that have different color. That's a good indication that something is wrong with them. Probably layer name. And same story is with this line here. This circle here certainly doesn't belong there. And these lines have also different color, but these are classified as existing ones with code 100. So in the next step, we can use one of these custom built FME server apps to validate that. If we just drag and drop a CAD file into the application, and when it's uploaded, we can run the app. In the background, there is a FME desktop workspace that will create one HTML report that you can download, and then you can bring it in your browser. There is an example of that report. I'll just zoom in a little bit. And here are the all errors listed. These two lines, this one doesn't fit into the ITM boundary. If we zoom into the main area of the drawing, we can see all errors like this intentionally wrong layer name identified here. And these some of the buildings actually had overlaps, and this circle doesn't belong there. A list of layer names, a list of errors containing the handle. Handle is useful to identify these objects back in the AutoCAD file. And at the end, we can print that report out if we want. Once this validation is done, we can go back to CAD drawing and fix these errors and rerun the validation again. Beauty of this is that you can deploy this application somewhere on the web, let contractors upload their drawings, validate them, fix the errors, validate them again if necessary until the validation is complete. You don't have to have a person dedicated to validate their drawing every time again and again. Once this is completed and there is no errors, you can transfer this to the GIS file, GIS information like this. It can be part of the previous step validation, and once validation is successful, it can push directly to something like AGOL, or you can request drawing makers to submit you drawing, and then you can validate it once again. and then run this translation as a part of the separated process. This is the way I did it here. And the end game is drawing like this, published directly, published to EGOL, containing the land registry parcels with attributes and buildings as a polygons. This information can be enriched with any other attribute information from any other file. For example, you can use database of land registry parcel owners and merge these two together and push that to EGOL as well. So that's it. Thank you. Any questions?
Thanks, Hrvoje. That was brilliant. And again, I suppose it's a very specific example in terms of CAD, but again, it's so important for a lot of our customers. So these are real world examples, just anonymized for the sake of presentation today. But again, for some of our utility customers, it's amazing, especially when you think how much outsourced contracting support that they get, whether it's fiber, electric, water, even transportation or infrastructure. So again, instead of them having to receive these files in, manually check the contractor's work, then go back with feedback, then get it back, recheck it again and send it back out, to have that, again, enterprise automation where they can literally have an online portal. And again, we can have a username, password in front like we do with some others, where they can log in as a contractor, drag in a file and automatically get that feedback straight away. Quite quickly as well, you'll see the quality of the data coming in from these other agencies improve because it's a machine that can't get past it. So again, the quality tends to improve over time. Another point just to call out is, again, we're using CAD data. This could be GIS files, it could be Excel, it could be a planning application. Again, the possibilities are endless. It's just that workflow, automated workflow in terms of taking a particular piece of data, validating to make sure that it meets your business rules, and then obviously distributing it out as it goes along. Thanks for that, Hrvoje. I'm going to hand over to Ciara, I think is next. Yeah, Ciara from OSI is going to be presenting next on Prime 2 products, automated map production. Hi, Ciara. I know you had some issues earlier on, but yeah. I think you're up and running.
Can you hear me okay?
I can hear you great.
Perfect. Is that coming through?
It is indeed.
Great. Okay, thanks, Garrett. As you said, my name is Ciara Beddy. I'm the Geospatial Product Development Manager here in OSI, and what I'm going to discuss is automated map production with FME and essentially taking Prime 2 to product. So quite a number of years back in 2016, OSI, we consolidated all our digital mapping into one single national database, and I'm sure many of you are familiar with it is Prime 2. And it is since 2016, what we have done is we've built on this to create a framework of automated GIS-based processing that allows us to take our Prime 2 products or all our national products out of our Prime 2 database in an automated manner. And that means with zero manual intervention. So what I'm going to look at is how we have used automated map production through our FME Flowlines. So it's the concept or theory of automated data or product creation within OSI and what that actually means to us, process itself, and how we've integrated FME for the use of automation and data, and then the product, some of the results and successes that we have seen with using FME. So who are we? I'm going to use the royal we a lot during this presentation. So we work within the Geospatial Services Data Governance and Quality Department, that is GSDGQ. And this is really the department that maintains our data. So our spatial database teams, data quality and data governance, and then the teams that actually produce product from the data. So the likes of our geospatial web services, and then the product or the teams that I work with, which is product generation and cartographic design. And these really have a lot of expertise with output of automation and map making. So these two teams, they are fully responsible for delivering product from Prime 2. And that can be anything from your DLM vector-based products, as well as our cartographic PDF, TIFFs, and all the paper-based products that you might see in the marketplace from large scale all the way up to small scale. And our goal, it really is simple. We want to fully automate all our product, no matter what the format is and no matter what the scale. So this is the royal we, product generation and cartographic design. So looking at the actual concept then, where are we going and where are we coming from? So when I talk about fully automated product creation, what does that actually mean to us? So really at present, when we are looking at some of our products in the market, and specifically paper-based products, it takes a considerable amount of time to get those products to market, and we sometimes unnecessarily duplicate efforts in the updating of data. And that really does have a negative impact on how long it actually takes product to get to market. So map production, truth be told, it really has been seen as kind of a standalone task where you're compiling information from various sources, and cartographers, they're really manually placing features on a map to get the most cartographically pleasing and aesthetically pleasing output. And it's only really been in recent times that we begin to challenge this traditional view of map making. And that's with the availability of new technologies that have allowed us to combine generalization processes with cartography and automated label placement. So that's where we are coming from, the legacy, actual manual flow lines. And we're trying to move into this future of automation of all output, no matter what it is, whether it's a paper map, digital map, so on. So how are we actually going to do this, and how are we doing this? This is through our automated IMGS system, multi-resolution data store. And this is quite a complicated graph, but to explain it as simply as I can, IMGS is made up of a series of automatically generated databases, and they house data relevant to a particular scale, then extract product from. And they are all derived from Prime 2. And that's the important bit, the fact that all of this information is taken from Prime 2 and delivered up to these data stores in order to extract product. And it works on our principle of we capture our data once and then we reuse it many times. So we have a series of DLM databases, which is our digital landscape model. And this just describes a geospatial database, points, lines, and polygons without any cartographic styling applied. So we have these automated processes of generalization from DLM to DLM to reduce the level of data that is available in that data store in order to produce a product from it. So each one of these green lines represents an automated process of code and scripts that we have built in order to do this automated generalization or simplification of data. And then on the right-hand side, we have our DCM databases, which is a similar concept. These are just digital cartographic models, and it's processed Prime 2 data with cartographic styling. And I suppose the simplest way of explaining that to everybody is we apply cartographic processes to the data in order to make them as aesthetically pleasing as we can on the product output. So the likes of, you may have 5 car parking symbols in a town, very close proximity to each other. We would reduce that down to 1. Or when you apply your styling onto the roads, these might clash at each other with the scale of 1:50,000, and you might want to displace and pull them apart from each other. So they're the types of processes we run on the cartographic side. And from there, you can see over on the right-hand side, as we produce these different scale maps or databases of local, in this range of 6 to 20,000, we pull the likes of our town mapping street guides, regional 25 to 100,000, the likes of our leisure mapping of discovery series, adventure series, and then up to national 200,000 to 1 million. We have our smaller scale maps such as road atlases, holiday series, and so on. So that's the rather complicated theory of it. The process and where FME comes into it then, at a very high level, because I kind of skipped over this automated generalization processes, what's actually happening in the background is we have our source data sitting in Oracle. We run these series of automated rule-based logic, and that comes in the form of Python scripts, model builder models, and indeed FME flow lines. So these are manually run on the data. You get your completed output, and then we automatically assemble a product to deliver it out to market. So that's the high level theory of what is going on in the background. And at this point, you might be saying, well, where does FME come into all of this? And the truth is, until about 2019, FME had no place in our MRDS process at all. And I've written up there the challenges of automated data creation. We had many, many challenges to build the rule-based logic that actually can generalize and apply cartographic processes on a national level against all our data, and to interpret flow lines that would have been manual in the past was incredibly difficult. But the team got to a point where we had these flow lines in place, and our big problem in 2018 coming into 2019 was the actual completion of automated processing of those DLM and DCM data stores on a national scale. And what I mean by that is we have 50+ million features in Prime 2. We can't just throw all those features at one of these rule-based processes and expect an outcome. They're extremely memory intensive. So when you go to run it, we actually have to partition the whole country, split it up into smaller little sections, as you can see over here on the right, and run our processes on these individual sections, and then stitch it all back up together afterwards as if we ran it in one single block. So our big problem in 2019 is we had software that would process and run all our processes on these individual partitions. It wasn't working very well for us. So that was our big problem, and getting a national output and getting it in a timely manner, which is important also, because we don't want to spend weeks processing this information. And because we didn't have national output, the reality was we couldn't validate that data. And because we hadn't national output that was validated, we were not in a position to actually create any digital or paper products from this data. So that was our big issue in 2019. And it was at that point we really began to look at FME seriously and see where could we build it into the flow line to actually get this job of MRDS done. So this is the technical bit. Remember, our problem number 1 and 2 was processing all these flow lines on a national scale in a timely manner. And what we came up with would be the best to describe it as a command and control center, I guess, for distributed processing of all these little AOIs into a national output. So what we have is a ProdGen user will come in and run a script that starts our, we built to process this information in 2 locations because we want to process it quickly as we can. At that point, then half the country starts processing on one server and the other half on another. And then FME controls how many of these AOIs or partitions are processing at any one time. Typically, it's about 4. So we have 8 jobs running at any one time. It uses mostly Python, uses the Python caller in FME to run all those models that I referenced that we built in Esri technology. Once they're completed, it drops it into an append folder to signify that data is ready. And then FME server is always watching that append folder. It picks it up, merges it into a national data set, and then goes into this phase of stitching it back together, which we call edge matching. So that's kind of the theory of what is happening, and FME is always monitoring this whole flow line and giving us updates and dashboards of exactly what's going on. So when we're talking about the actual FME workspaces, and in terms of, you know, many of us have built very, very large workspaces, these aren't significantly big, but they do a very good job and they do what we need them to do. So that's 2 workspaces there, parent, bottom. So the parent starts passing in these AOIs that you see over here. We use the Python caller, runs all our models, spits the completed data out. And then we go into FME server, appending each of these together. And this is, hopefully you can see it, the issue I was referring to for edge matching. Once the data is merged in together, you have this on the right-hand side was processed by one job, and the left-hand side was processed by another. And what you have is this division line kind of running through our way polygons, and that needs to be dissolved and merged so we can have one seamless national database. And FME does all that flow line for us very successfully. It sounds easy, but it's actually quite complicated. And all the while FME is monitoring and using one of my all-time favorite transformers, the HTML report generator, to produce these dashboards for us and give us all this low-level detail of what is exactly processing, how long it's been processing for, what progress it has done, and so on. So though the flow lines, I suppose, are very small, this was an extremely significant win for us. It allowed us in 2020 to decommission the software we were previously using and then go full blown into FME to process these data stores for us. And I've just thrown in here, you know, FME is the command and control center, but we do have a lot of FME models that we've built to actually manage the cartographic data and improvement of data that goes on maps. So I just threw in this really small example to kind of indicate what we would use FME for in the placement of data on maps. So when I was talking about our legacy in the past, our cartographers, this is a 50K map here, the Discovery series, would have placed this label here, Browhead. They would have physically decided the best place for Browhead is over here on the right-hand side in the sea. They made a good decision. Here on the right-hand side, this is a very early version of one of our automated products. And you can see Browhead is smack bang there in the middle of the headlands because it is using a headland geometry placed there in the headland and it is labeling it from an attribute. So we don't have labels as such within our DLM data. So to a cartographer, that will be sacrilege. There's no way they were going to pass a quality check and allowing things like our points and headlines clashing in on the actual geometry. So a very intelligent person on the team said, let's look at FME to do this. And they came up with this kind of flow line of intelligent label placement through spatial analysis. So you've got here the star, which is the actual physical geometry. And what they've done is create a 1 kilometre buffer around the headland point, identify the water bodies that intersect, which would be the sea, and then only keep the geometry by clipping out and identifying a new centre point of gravity. So you're moving our label placement point away from the original feature over into the sea. And then using a neighbour analysis between the headland and the point, we can determine what kind of orientation the label should have. So now we've got a new feature point and we have an attribute to say east, north, south, west. And then when we go into, we use Esri software, Maplex, to generate our labels, we have much more intelligent information that we can budge all this labeling off the actual headland geometry. So you can kind of see the improvement here. Three Castle Head would now be out in the sea, Mizzen Head, Browhead, and our cartographers are happy. So just going into the results here. We've now solved problem 1 and 2. So we have national seamless database that's topologically consistent at core, local, regional, and national. So big win for us. And this is where I was referring to the DLM, and you might see a little bit more detail of what I was saying. We've gone from highly detailed information at DLM core. We reduce it and simplify it to data that's suitable for that scale at local and regional, all the way up to national, where we have the simplest data represented. And then below, you've got the DCM core products, which are cartographic products that we would extract from each of those scales. Then getting into problem 2, if you remember back, we now have a national output, so we can look at validation. And I could probably give you a whole presentation on our validation processes. But to summarize it, FME deals with all of our DLM and DCM validation. We're looking for the likes of overlaps and gaps because we want a topologically consistent database. Slivers, you might just see here spiking that can happen with automated generalization. Self-intersections, multi-parts, connectivity issues. Over here on the right, you can just see these are 2 rail lines and each one processed by a little job. So that edge matching I was talking about earlier, we want to make sure everything's snapped back together so it looks like a single feature. So identifying where this didn't happen correctly or duplicates happen across 2 job partitioning lines. We have a whole ream of attribute validation to check that our forms and functions now make sense after they've gone through these validation processes, and comparative counts between data stores. So at core, picking one example there, the library, we had 137. By the time we go through all these series of generalization processes, do we still have 137 at the end of it? And in that instance, we'd lost 13. So we'd have to go back and find out what exactly happened. And then different DCM validation processes, the likes of these clashing symbols or symbols on roads. And we have a whole variety of label placement analysis. So FME, again, another huge win for us. And we did look at other softwares to do validation, but we firmly landed on FME, and it really has provided us direction on where to place development efforts to improve our product outputs. So finally, last problem, problem floor, we couldn't actually automate the production of this output until we had validated it. We validated it, and now we use FME in all our automated cartographic output flow lines. So FME is doing the body of work that will stitch all these templates, frames, legends together and output a product for us. So there's no manual job in it. FME does all of that. So from 2021 to 2022, we've been quite seriously producing automated product from MRDS, the likes of our rally maps, working with the RIA on custom 5K products. All our place maps and planning maps are coming from the system. Eurogeographics data and open data supply this year from the DLM stores. Compass mapping, which we hope to release this year, which is self-service site-centered mapping that customers can come in online and pick 25 or 50K areas and produce a product they can add their own cover onto. And then we still have a whole range of products that we're in transition with, such as the Discovery Series, Adventure Series, Holiday Series. We have about 17 paper-based products in the market at present that we are trying to transition over to this system. So we are in no ways complete. We are working our way through. So the results then for us, I think primarily and most significantly, this way of automated map production, it provides better quality products in the market for the simple reason that when something's updated in Prime 2, in a single database, we can filter it out to many products very quickly. And it's going to drastically reduce the time we get updates of these products into the market. It also increases in consistency across all our product offerings. And by that, I mean, we're using rule-based logic to generate them. So it's not individual decisions making different decisions in different areas. We also have national coverage products at many scales, which we never had before, such as 10K and 25K. And then, of course, it brings efficiency, flexibility, and cost reduction back to the organisation. FME, it is the control centre for all our automated map production, validation, and product output. It makes automation look easy. To be honest, it hasn't been easy, but FME has really done a good job at making our life a lot easier than it ever would have been without it. So, as always, FME, it gets my stamp of approval. And
it was again an amazing presentation. I gather very few hikers, when they're holding one of those cartographic maps in their hands, when those series realizes what goes on in the background to be able to generate that particular product. It is incredible. I think there is one or two questions, but I just have one for myself. You show that example of the railway not stitching and the validation. Is there any examples where I suppose there's that stewardship model where FME just cannot figure it out and it has to go to a human to go, I need to see what's wrong here, I guess. Is there many examples of that?
Our whole principle is no workarounds. We don't want any manual intervention. Now, other mapping agencies probably are less strict than we are. They might say they get it to a certain point, but we have really worked to the principle of we'll let FME find where the solutions are or the problems are, and then we need to go back to the process that caused that problem in the first place and correct it so it doesn't happen again. So yes, they are there, and it is probably what has taken us such a long time to get to the now, because we're talking 5 or 6 years, because we do not manually intervene. So it does happen, Garrett, but we're working on that basis. Yeah, that we don't go backwards, we go forwards.
And then just, I suppose, off the top of your head, I suppose in terms of data volumes, you mentioned like over 50 million features, like, and you've obviously split across the 2 different servers. Like, what type of volumes of data are you kind of churning through in some of these processes?
For the likes of that DLM local, which would cover the scale of 6K to 20K, I think it is. We would be processing 55+ million features. I don't know what we actually bring it down to in local, but it takes us approximately a week to process all that, even though it's running on 2 servers to get an output. But at the same time, if someone was to manually do that, that time frame to get from 1K to about 50K was 5 years.
Oh, wow. Okay. Wow. That's
so,
incredible.
You know, in terms of return of time, you know, it is the right direction to go for us.
Brilliant. And I have one question from the audience. Have you looked at translating or migrating the Python scripts to FME transformers, or are they too complex?
A lot of the Python scripts, they're using Esri toolset. So it's probably easier. We just use ArcPy. We put the ArcPy into the Python caller, or we use ArcPy to call the models, which uses Esri functionality. So we're trying to combine the best of Esri and FME, and we take what works out of both and what tools are the best in both technologies.
Brilliant. Thanks, Ciara, and thanks, Pat, for the question. I won't keep you any longer. Ciara, as always, thank you so much for presenting a really, really interesting presentation. And yeah, we kind of see you nearly every year, so I'm going to say I'll probably see you next year.
No,
so.
you won't. We give somebody else
Okay,
chance.
no, we'll give you a year off. Brilliant, which is good.
Thanks, Emil.
Thanks, Ciara.
Thank you.
Oh, actually, sorry, one other thing, Ciara. I know you had trouble logging in, but we're talking about obviously those HTML reports. I was just jotting things down as you were speaking. Obviously, in FME 2023 in server now, you'll have quite granular reporting on, I suppose, how those engines are being used, the distribution, the network, and stuff like that. So I don't know if you missed it this morning from Don's presentation.
I
but
did.
Again, that's
I'll have to catch up.
Again.
Yeah, no, we'd be definitely
Yeah,
interested. We use all that reporting across actually a lot of our systems in OSI. So it is. I'm a big fan.
Thanks, Ciara.
Thank you.
See you now. Up next is myself and Ardi from Safe Software. Just let me go and share my screen. So there's a disclaimer. I'm going to put it in, Ardi, so you don't have to worry. We have not rehearsed this because Ardi has been traveling. I think he's currently in San Diego, a hotel room in San Diego. So Ardi, I really appreciate you coming along and presenting with us today.
Yeah, my pleasure.
What time is it over there at the moment?
It's at 4:30 a.m.
Oh, so sorry. Okay.
No worries. My pleasure.
So we'll fly through this, and I suppose as we just mentioned already, I suppose today's presentation was around, I suppose, enterprise integration and that scalability. Garrett from obviously IMGS and the commercial manager, as most people would know, and then I have Ardi, who's the channel team lead at Safe Software, and I have, so obviously we're both business professionals, something that we're very proud of, that new certification. Which is great. So I guess as Don had mentioned at the start, and I was actually going to put in my opening slides, but I had seen Don, so I didn't want to kind of steal any of his thunder, but it's clear that the value of spatial data is starting to rise. And that's amazing for us as we've known it for decades, or in some cases multiple decades for people that are here today. But I guess the future problem for yourselves is that the request for that data will increase as more and more enterprise systems start to use and utilize spatial data. The requests into yourselves will become more and more evident. So again, I won't get too much in this kind of generic slide, but again, we're starting to see organizations that are understanding by taking in spatial data, along with obviously enterprise information, they can start to increase sales, drive revenues, improve operations, whether that's from an asset management standpoint or tracking or any inefficiencies that are out in the field, but then also increase situational awareness. So again, these are really top shelf boilerplate examples of the benefits of using spatial data. But again, using Michael's example of being able to take that from a business intelligence platform, take it out and report on that type of information as well, is obviously literally helping improve the services to customers and improve hopefully response times to save lives, which is incredible. And I suppose the power that comes behind FME, and again, I mentioned this at the start, again, it's that 450 out of the box systems that it supports. I think it's up to, I think maybe 1,000 if you go onto the hub. There's a lot of custom transformers that people have created and have put up there that anybody can kind of take and download. And that data being able to transformed in over 500 different ways. And again, automating those workflows. So again, it's going to be as enterprise integrations or flow lines come through your organization, and that demand for spatial data becomes higher. Again, you need to be resilient to make sure that, I suppose, having the support from both IMGS and Safe Software to be able to scale and deploy anywhere is so important. And again, I had shown this earlier on, and I won't labor it too much, but again, it's just those enterprise integrations. It's no longer just people requesting, show me what houses that we own, local government houses in a particular area. Now the requests for data, both from citizens, from other organizations, from national agencies, are getting more and more complex. So you need to start pulling data from Azure, AWS, Snowflake, taking IoT information, and then other enterprise information. So again, stuff from maybe AGOL, from Map Enterprise, Snowflake, Microsoft, etc., and then bringing them all together to improve that decision making further on down the line. And again, I showed this slide at the very onset, but again, this is where over probably the last 3 or 4 years since Safe Software starting to engage with Gartner, geospatial will always be that core pillar for FME, but again, it's starting to look at that further for the enterprise. So again, these engagements with the likes of Gartner are starting to open up Safe Software's eyes to actually what is it that users want in terms of a deployment. Do they want to make it easier? Should we have in easier ways to do quality control, stewardship, etc., all the way through it? And I suppose that's what's driving this kind of enterprise focus from Safe Software. And Ardi's just going to talk about, I suppose, how they've taken maybe some of that feedback from Gartner and started to look at how FME is deployed.
Yeah, thanks, Garrett. So one thing you'll notice over the next few slides is we're going to be talking about deployment quite a bit, and deployment in various different capacities. So first off, it's deploying the actual technology within your environment. So as you can see here, we're data agnostic, we're platform agnostic, so we don't really have any sort of requirements as to how you're hosting and deploying FME. You can self-host it, the hardware or machine, if you like. And this relates to both FME desktop and server, which are both on-premise products. If you are looking to leverage more of a cloud capability with FME server, we have FME Cloud as an option, and FME Cloud is essentially FME server hosted on Safe Software's AWS. The value that you would get from a usage perspective is that it's not eating into your infrastructure costs, and you don't need to worry about having to stand up another technology in any of your servers. Safe Software is managing all that, and because IMGS is a managed service provider of FME Cloud, they're also able to provide the as managing the backend of the FME Cloud, and being sure to do any sort of backups and disaster recoveries and the likes and such as well. From a deployment perspective, as well as I mentioned, we also do offer deploying FME in your own virtual machine, which is where the cloud marketplaces come in. You can right now deploy FME in your Google Cloud or your Microsoft Azure marketplace as well. Now, these are on a bring your own license model. So if you currently do not have a license of FME and you'd like to deploy FME in your virtual cloud through Google or Azure, please reach out to us first. These are the different various types of operating systems that we support, and this is not by any means a limited list of any kind. As I mentioned earlier, our focus is being agnostic, both from a data perspective and a platform perspective. So whether you're looking to deploy FME in Windows or Mac or Linux, Docker, we've been hearing a lot of customers starting power of Kubernetes. That's definitely an option as well. And of course, as I mentioned, for customers that are looking to leverage the power of FME server but don't want to worry about hosting it or deploying it on their end, we have FME Cloud as an option, which is a fully hosted FME server on Safe Software's AWS infrastructure. And these are the two cloud marketplaces that you can find FME in currently, Google Cloud and Microsoft Azure. We are in the process of working on getting marketplace as well. That is something that we are working towards. So hopefully in the next few weeks or months, we can have an update on that, and we'll be sure to update the team at IMGS when that is done. So if any of you are running on AWS and you'd like to deploy FME in your virtual cloud through the AWS marketplace, you would have the option to do so. So another aspect of deployment that is important for us is when it comes to deploying the licenses itself. And there's various different ways, three main different ways of how we offer licensing here at Safe Software. The first one is one that we're all very familiar with. It's a perpetual model, the named user license, if you will. It's a license that you basically buy up front. You own that license. That's an asset that belongs to the organization now. And you pay a 20% annual maintenance starting in year 2. And the annual maintenance that you pay basically covers your support, covers the upgrades, covers any sort of releases that are coming out. And it's really good for organizations that are either small or they're getting their feet, or they're getting the feet into the FME platform. Organizations that are looking to get into a more larger deployment or looking more flexibility, that have more use cases defined of how they want to incorporate FME in their enterprise. We have our subscription offering available as well.
And perpetual, I suppose, Ardi has always been the core, and it's been kind of the staple for everybody for such quite long, and it's suited to so many organizations and still does suit so many organizations. I guess just now, and the theme of today obviously has been around the enterprise. It's then, how do I have that flexibility? And I know you're going to touch on it now, to then scale up, I guess, and I can't go to tender or for out to procurement every single time I need an extra engine or an extra license. So yeah, as you grow, it can grow, I guess, and perpetual has been great to this point. It's just, I think, looking at the future, I guess that's kind of where we're starting to see that change, I guess, in the subscription side.
Yeah, totally. And look, one thing I'll mention as well is that there's no right or wrong way of doing business with Safe Software or IMGS. All the options that you see in front of you right now are viable options. It's just, as Garrett mentioned, the value that the customer gets out of some of these options, one is greater than the other. So on the perpetual side, again, it's great for customers that are just getting started with FME, that they might know what they want exactly just for the one-off project they want to work on. But customers are looking to get into more scalability, and they want more flexibility, and they want to be more agile with their ever-changing business needs. That's where these subscriptions and these CPU pricing is starting to come in to take more shape. And it is becoming more cost-effective subscription side to the leverage, because as you grow your licensing needs and your licensing in general with FME, it doesn't necessarily increase your annual costs right away. What happens is typically we look at the renegotiation or the end of the term as an opportunity to evaluate your licensing currently and your licensing needs in the future to determine what price may be. So that's on the subscription side. And the one thing I want to also touch on from a licensing perspective is on the CPU side. So you see that CPU usage pricing on the far right. That has to do with the deployment option or licensing option, if you will, of FME Server. FME Server out of the box, again, it's an on-premise solution, and it's if you're processing jobs for organizations that might have jobs that are sporadic or jobs that are unknown, but they require a lot of attention, or even if they want to get into parallel processing and they want to be able to run multiple FME servers at once in order to be able to handle multiple jobs being processed at once, that's where the CPU effect. You're no longer paying for the server itself, but you're actually just paying for the time that the server's on that's processing those jobs and automating those jobs. And it can be incorporated in our subscription offering, or it can be incorporated in a perpetual model as well.
And when Don was mentioning today, he touched on the remote engines. Again, you could see that, I suppose, being used in those situations where you've got data around, and again, high volume but low frequency. Again, just throw an absolute heap of engines at it to process. Even just thinking of Ciara's presentation beforehand, and again, the scale and volume. Again, if that was up on a cloud platform, that also has that ability to scale along with the engines. Again, you could probably do some really clever stuff in terms of reducing that time, not from weeks, but down to probably hours. But obviously, there's a cost implication for that, obviously from the cloud provider, and then obviously from the CPU. But again, as you had mentioned already, some customers will sign value in perpetual, others in subscription, and others will CPU usage. So it obviously depends on each organization.
Yeah. And subscription side, we have various different industry-based subscriptions available at SAFE, and you can see all of our pricing on safe.com/pricing. So one of the subscription offerings that we have is a local government subscription. It's the pricing is based on population tier, and it's really designed for the small and mid-sized local and regional councils, and it's helping them get into the FME platform right off the bat. So no longer a small deployment on FME desktop and then moving into server afterwards. It's about getting into the FME platform right away and getting the whole value of the enterprise data and application integration automation at your hands with the subscription offering. And the one thing I'd like to also make a note of is when you see unlimited FME desktop and server, we truly mean unlimited. And I think, Garrett, customers that IMGS has worked with where their needs are increasing, their demands for FME engines or servers or desktop is increasing, and it's sort of helping you to say, hey, here's another asset, here's another license, here's another license file for you. Let's get working on that next project.
Yeah, no, 100%. And we've seen it. So again, we've probably only maybe about 5 or 6 councils so far who've moved over to or are at that stage, I suppose, on their data journey in order to be able to move over it. But again, yeah, unlimited. One council in particular, I think, deployed something like 60 grand worth of software in like the first day. And that was actually talking them down from nearly 100K. But again, it goes to show of, I suppose, they had the need for that level of software, but I suppose the barriers between procurement and tendering can kind of get in that way. So I suppose once we get over that initial threshold, again, you can get in there and it's just an email to IMGS, and within 24 hours we'll have your additional server, your additional engines, etc. As well, I suppose you had mentioned the pricing guide that's up on Safe Software's website. I suppose that's probably a little bit more North America focused, and we do have localized pricing here in Ireland. So do reach out to myself if it's something that you want to look into. And again, that's something that we can come in and might have a cost-effective manner in order so you can scale and start to tackle these other enterprise questions that come up.
Yep, absolutely. Yeah, and for organ outside of the population tier on our local government the pricing or any of our industry subscriptions in general, we also have this enterprise subscription, which basically covers everyone. It's an umbrella subscription, if you will. And it's very similar to the local government or the industry subscriptions. The only between the enterprise and the local government one is that the enterprise subscription, there is a threshold put in place, and that threshold is based on a negotiation between the customer and IMGS, based on what that fair threshold is. Again, you're able to leverage the full power of FME platform right away into reaching that threshold, whether it's within the first year or within the second year. Again, working with IMGS, they're able to provide you the guidance as to how it's going to help you from scaling into your next renewal and how the pricing will look as well. But ultimately, all these subscription offerings that we have, whether it's a government one, whether it's an one, our focus is one thing and one thing only: ease of deployment for you, ease of deployment for our partners. If we can make it easier for you to deploy FME, as you saw with OSI, with their mapping needs, if we can make it easier for our partners to work with you to deploy FME, it makes it easier for you to do your job and to leverage the power of the FME platform in order to automate and simplify your business processes all across the board, whether it's within the spatial side or the non-spatial side.
Brilliant. And that's a good point, I suppose. And that's how OSI, people like the Valuations Office, and even Dublin Fire Brigade through Dublin City Council's enterprise agreement, again, can tackle these, I suppose, there'll be heavy processing requirements where they can deploy multiple engines to be able to tackle these different enterprise use cases inside the organization. One that I just wanted to touch on, Ardi, just really quickly, it's just because you're breaking up a tiny little bit, is just around, I suppose, the startup subscription, which is new from Safe Software. So again, for new users, it's great to know that, or sorry, for new organizations, it's nice to know that, I suppose, at an extremely low cost, basically free in year one. You can reach out to us, and again, if you want to start looking at leveraging out of spatial data with inside applications you're trying to design yourself, or solutions you're trying to design yourself, that you can reach out to ourselves, and from there, again, we can help support you. But in return, we do want, obviously, that you are promoting, you are talking about FME, so again, that we can really kind of help that from kind of day one, or from a foundation level, to help you grow, and then obviously help other startups in the industry to be able to get up there. And then again, just subscription benefits. And I know this is probably more of a commercial presentation, but again, all day we've spoken about how we can scale for the enterprise and the new challenges. I thought, or Ardi and I had thought, that it would be important to talk around that. Yes, FME can be deployed anywhere on nearly any different type of platform, but also we can put the licensing behind you from a commercial standpoint to support you as you start to grow and take on more enterprise level workflows inside the organization. And again, we can be quite flexible in terms of what works with you over a 1 year, 2 year, 3 year, etc. period as well. So I think that's important to call out. Ardi, I want to say thank you for staying up so late. I am so sorry. I didn't realize it was so late. So thank you for your time. And yes, if anybody has any questions around anything that we covered from an enterprise perspective in terms of from subscriptions and how you can grow inside your organization, don't be afraid to reach out to myself or Ardi, and we're happy to have a conversation with you.
Absolutely, and it was my pleasure. Thank you, IMGS, for inviting me and allowing me to be a part of this, and thank you for listening. And as Garrett said before, the pricing that you see on our website is guidance, so reach out to Garrett and IMGS, and we can definitely see how we can make the subscriptions fit your organizational needs.
Brilliant. Thanks, Ardi. Go fall asleep, collapse, get some rest, and we'll see you again soon. No problems. Thank you. Brilliant. So we have, I think up next, we have Robyn from National Broadband Ireland. So again, Robyn's going to be presenting on their use of FME. I want to thank Robyn for coming in last minute and agreeing to do a lightning talk. So thank you very much.
No worries at all. Delighted to be here.
I also wanted to congratulate you on your recent certification. So well done
thanks.
on being recently certified as well. So congratulations on the last week or so. So no, it's great. It's great to have you along. I know we did a bit of a dry run yesterday, but if you want to share your slide deck, so just on the left-hand side underneath stop camera. Take your time.
I think the whole thing is frozen on me.
You're all right. So if you just click on the browser, you can just click refresh. So it will just take you back out and bring you back in. So if you just press enter on the URL and just do a refresh on the browser.
Yes,
that's it. Yeah, it is. Yeah. So if you just, it's not in presenter mode, just so you know. So if you want to press present.
Okay.
Yes, perfect. And I can see that. Great. Yeah, no, absolutely brilliant. I'll mute and I'll hand over to you, Robyn. Thank you.
Thank you. So as Garrett mentioned, I'm Robyn Dennehy, and I work as a GIS analyst here in NBI. So just over the next kind of 10 or 15 minutes, I'm just going to give a really quick overview about, I suppose, how we're using FME in NBI, and I suppose a few other bits on where we'd like to, I suppose, go forward with it as well. So this slide here. So a bit about us, for anyone that might not be aware, National Broadband Ireland, NBI, we are contracted by the DECC to roll out the National Broadband Plan across the island of Ireland, where we'll deliver high-speed broadband to every rural home and business in the intervention area. So that's about 560,000 premises, including farms, businesses and schools. It's actually the largest telecoms project ever undertaken by the Irish government. And it's actually the largest of its kind in Europe as well. So a really good project to be a part of. We're not doing this by ourselves either. We have some fantastic industry partners as well. So we have them on screen there, including Secto, KN, Gaeltech, Octavo, Indigo, Air, Nokia, and DSB. So there's a good few of us involved in this, and I suppose it's absolutely fantastic to be working with all of these people as well. So this slide here, we just did a few, I suppose, statistics, a little update, progress update on where we are to date. Up to date as of the end of September 2022. I won't read out all the numbers because I probably spent 10 minutes getting tongue-tied over it, but I'll just leave that on screen while I just explain maybe how we're rolling out the plan. So we've divided up the country into deployment areas, or DAs, and there's 227 to be exact, including our islands as well. And each deployment area goes through a survey, design, build, and connection phase. And all of these phases are underpinned by geospatial data. So it's a telecommunications network that we're building or improving on. So because spatial data underpins all of it, we do need systems that and systems and processes that can kind of integrate really well with each other and allow for data translation as well. So that's exactly where FME comes in. We have 2 database edition floating licenses at the moment, and these are installed on a license server manager on our cloud-based EC2 instance. It is dedicated to our GIS team, and we connect into that from our AWS workspaces then. So everyone on the GIS team here, we all work on AWS workspace instances. It just allows for, I suppose, better data processing. Our poor laptops wouldn't be able to keep up. So we connect into those floating licenses as and when we need them. And as recently as yesterday, we've 2 more on the way as well, which we're absolutely thrilled about. So I suppose a little bit about a few current FME use cases. We do a lot of ad hoc requests for people across the business, kind of data conversions and exports from different spatial systems like ArcGIS Online. But then we also have, I suppose, more solid workflows that we've developed across the entire project, from design, build, connections, and then that will expand as well as we get more into the process or into the project. So I have a few on screen here, I'll talk through them as quickly as I can. But if we look under the design section, we have our wayleave spatial analysis. So wayleaves are required for installing certain infrastructure, depending on where that is. So we do spatial analyses to, I suppose, clash against PRAI data, OSI data, those different data sets, just to make sure that where we're installing infrastructure and a wayleave is required, we definitely have all that ready to go at our build stage when people are going out to connect up the network. We also have our national data set management. So our national data sets play a big part in creating our designs. So such as AIR, PRAI again, ESB data and OSI data as well. Our GIS team manages and maintains those data sets, and we've set up those different workbenches in FME to, I suppose, streamline that process and those data updates as well. And I have a snippet of a workbench as well that we'll hopefully get to. But again, it's pulling in kind of DGN files, GML, shape files, all different data formats, and we're able to write those out almost seamlessly to our SDE databases, which is absolutely fantastic. And then another one under the design section as well, we have our DECC submission report automation. So a bit about that. Once a design is completed for a deployment area, NBI submit the design and a series of reports to the department. And the department need to review all of those before the DA gets approved to go to the build stage, and before our build contractors go out and do all of the work on site. So we create a load of reports and kind of spatial clashes as well. So we'll be looking back at, designs where they started and where they're at now in our final design, and doing those comparisons to see what's changed. So there's a lot of different reports that are involved there, and we've been able to automate those with FME to kind of do those spatial clashes and have the output be in like a consistent way that the department can then view for each deployment area. So it's made it very scalable for us, which we're thrilled about as well. Moving over to the build phase, so the middle column there, just on our supervised access. So a colleague of mine kind of specializes in this area. It's, I suppose, a process that NBI and AIR share. It's kind of an over and back between both of us. But in order for NBI to core drill in an AIR chamber, we have to submit a supervised access request to them. And that will include photos and XY coordinates of the chamber prior to starting any work. So this process is done on a weekly basis with AIR, and the requests are either approved or rejected based on the information we provide. So we kind of need all of that data to be standardized, and there's kind of photo renaming processes in there as well to adhere to AIR data naming standards. So FME has enabled us to do that and have, I suppose, a uniform output that's going over to AIR for each of these weekly reports. We also have photographic evidence QC, and that actually comes up across the board, even the duct blockage bit further down and the tree trimming in the next section, because when infrastructure is built, there has to be photographic evidence taken to support the installation of the infrastructure. So we do a lot of validation and work on that information when it comes into NBI. And so FME provides a QC on the photos. So we check if they're geotagged, and if so, are the geotags within a given distance of infrastructure? So we're making sure that there's no kind of duplication across all of our different deployment areas, and all that type of thing. So photographic evidence QC is a huge part of our work as well. And I suppose in line with that, then moving on to the blockages, when we're installing new fibre cables into existing duct, sometimes the duct can be blocked, preventing cable from being moved through the duct onto the next section. So duct blockages would then need to be cleared. But each time a duct blockage occurs, we need evidence or photographic evidence of it being cleared for the department. So once NBI receives information regarding our blockages from our build partners, all that information is QC'd to check for duplicate blockage locations, that they're located in the correct DA, and that it's located next to the correct duct section. So kind of similar to the previous point on the photographic evidence QC. So FME has enabled automation of these spatial and kind of tabular data checks for us to be able to scale that all up. So if we have a few DAs in flight at any given time, we're able to kind of reproduce this process quite quickly and do that QC. So moving on to our connections section. So after a DA is built, we then kind of go up to the connection stage where the individual premises are being connected up to our network. But I suppose before all of that happens, we have our DECC map data processing. So after a DA is built, similar to at the design stage, we submit a series of evidences and finance reports to the DECC for review. These consist of kind of GIS maps as well, and they pull data from across the entire organisation. So we're pulling information from commercial teams, build teams, design, our local authority team, our finance teams. So it's a lot of information to be collating and kind of moving it into a format that I suppose is easier for individuals to interpret. So FME allows us to do that. We're pulling in data from Excel, from ArcGIS online feature services, JPEG photos, all that kind of thing. And we're producing final GIS map layers that go to the department. And it makes it easier for them to interpret all of that information and see what was built in the DA, and kind of check photo evidence if they want to, and all that type of thing. So we have it all in one location. And FME allows us to, I suppose, clean up all that data and make it all more easily accessible. I have the tree trimming data QC under that as well, and it does feed into the DECC mapping. We do tree trimming all around the country. It's important because where aerial lines are being installed or upgraded, tree trimming needs to be carried out so that our build partners can install all of the aerial lines safely. And similarly to the blockages, we need photographic evidence to, I suppose, support that those works were done. And we're doing different checks on that data, checking the spans and the tree trimming lengths, and just making sure that all of that data is, I suppose, clean and tidy, ready to go to the department. So that's another big aspect. I didn't think I'd be looking at trees as much as I have been over the last number of months, and it's been great. But then our as-built map production as well. So that's the final point on the connections section here. So once a DA is fully built, NBI receives a final design from our design partners. and that is loaded into our GE Small World system. So that's going to be used as our inventory management system going forward. But not everyone in the organisation would have a license to access GE Small World. So the GIS team, we work to make as-built maps available on our ArcGIS Online system, so that all the maps can be consumed by the wider organisation and anyone that needs to take a look at them. So the way the data is received in by the design partners requires an FME process to extract the data in a certain way. It kind of mimics our Small World script that is run to pull the data into Small World, and we needed to recreate that inside an FME and then load it into our SDE databases. So I do have a snippet of that as well to walk through very quickly. I'll change the slide here. So just super quickly before the as-built one, our national dataset management, I have a snippet here of a workbench that a colleague of mine put together. And you can see our data sources for the ESB data. We have DGN files coming in, and we're writing out 2 SDE feature classes, which are, I suppose, set up as templates in our SDE. The process is kind of filtering data by voltage attributes, and then we're also extracting labeling information, station point locations, and then writing that out to the feature class templates. Again, we have the workbench was huge. We had kind of the MV and LV aspects of it as well. But this has completely streamlined our ESB data update process, because you can just kind of click in, kind of download your CAD files, have them in one location, read them all in, and then it just seamlessly moves them through the process. So you're able to kind of click and go, which is absolutely fantastic. Kind of removes the need for manual appending into feature classes and that type of thing. So we're delighted with that. And super quickly on our as-built design as well. Our as-builts are received in shapefile format, and again, going out into our SDE feature classes. I suppose the key thing is that DAs, when they're at as-built stage, they're actually broken down into smaller sections called ribbons, and we receive the data in ribbon by ribbon. So to kind of mimic our Small World process, we need to kind of Frankenstein the data together. So we're taking it out of, let's say, 5 or 6 design packs, and then pulling it together into one map then on the other side. So this FME workbench, this is a snippet from one infrastructure element, but we have 12 others, chambers, poles, that type of thing. And it's filtering the data, it's splitting up kind of a unique identifier label. And then we kind of have a test filter which extracts just the ribbon information, and then that's kind of its identifier then to move it into the SDE, that we're just looking for this ribbon and not ribbon A and all other ribbons that could be in the design pack. Quickly on to my last slide here. Apologies, I think I've gone a shade over time, but just a few bits on our FME pipeline. So I suppose we're quite new and we're still establishing a lot of our processes. So this is kind of our short-term goals at the moment. And a lot of them are around improving processes that we set up kind of 6-8 months ago, to kind of make them even more efficient now that I suppose our requirements might be slightly changing and that type of thing. So the first one there, our blockages QC process. So we found that some of our photographic evidence coming in is exceeding the 10 megabyte limit, which ArcGIS Online supports. So we're moving to a kind of a hyperlink process where, you know, we'd have a field in a GIS table or the attribute table where you click to a hyperlink and the photos are stored in a SharePoint or a location like that. So we're updating our FME workbenches there to incorporate that in. Then another section there are drop connections. So when connecting from a network to the individual properties after the entire DA has been built, updates to the planned connection route can happen on site. So what we're hoping to do to keep our inventory system up to date is have GeoJSON exports from Small World and process those through FME and upload them onto ArcGIS Online editable maps. So then the build partner, when they're out on site, they'll be able to, I suppose, update infrastructure as they need. If something needs to move across the road, or, you know, you're going aerial instead of underground, or additional pole or something like that, that they can, I suppose, edit the data there. And then we'll pull the data back from ArcGIS Online once a home has been connected, and export that into our GeoJSON format, and then that can be loaded back into Small World. so that our inventory system remains up to date. And then I just have a small bit here on the DECC submission process. So we work with the department a lot. They're reviewing a lot of our work. So all of the reports and the workbenches we've set up to create those reports, they're all kind of standalone at the moment. So our plan is to I suppose, integrate them all together so that, you know, fun ends, you kick off the next workbench, that type of thing. So that's something in our kind of short-term plan as well. I think that's me. Thank you very much for listening to me talk. I hope that might have been interesting, but if anybody has any questions, please reach out.
Thanks, Robyn. That was incredible, and I think it's worth noting that MBI are probably only using FME, I think 12 or 13 months, which so like it's incredible what you've achieved in such a short amount of time. So well done to you and the wider team in MBI. Yeah, it's pretty amazing.
Thank you.
Don't think we have any questions so far, do we? Oh, question for Robyn. One sec. Are you writing as-builts into versioned or non-versioned SDE datasets?
Great question. I think they're non-versioned at the moment. So we're kind of working with different types at the moment, but the non-versioned datasets or databases, we're kind of receiving one ribbon at a time, so they don't all come in together, and we're just kind of loading them in as they're received. So non-versioned at the moment.
Brilliant. Thanks, Robyn. I'm conscious of time, so we're just going to do a really short wrap up now. So if I go in and share my screen.
Garrett, you have my presentation.
Oh, sorry. Yes, I have Ciaran's next. Oh, wow. I thought we were going to wrap up, so we are behind. Sorry, Ciaran.
I just want to say I'm living proof of what NBI are doing, because up until about about 6 months ago, a year ago, I would not be sitting here in my house with camera on and video streaming and doing all sorts of stuff at the same time. So we were one of the first people to get NBI, and it has been absolutely fantastic. We have 1 gig to the house, and previously we had 2 meg. So that's some transformer change there that we've got from NBI. So it's fantastic. So it's great to see that coming out in the country, and great for us to be supporting NBI and Ciara and Virgin and all the telecoms that use FME as well. The
IMGS staff are delighted that we get to see your face more often now when you're working remotely.
it's good. Sorry, just click the buttons here. Okay, so I will do this really quickly because I know we are overrunning. So final presentation of the day is just to show how we can transform manual workflow lines with FME. So business automation is a top priority for enterprises today. Around 50% of current work activities are technically automatable by adapting currently demonstrated technologies. And 6 of 10 current occupations have more than 30% of activities that are able to be automated. So the journey of business automation has many obstacles, whether that's data variety, velocity, different systems, disparate systems we heard this morning, real-time access to data, cross-team data sharing, or new customer demands and limited resources in IT. So with FME, I think this really just encapsulates everything we've been talking about today. We can save time and cut costs, reduce human errors, improve data quality, gain speed to insight, improve your customer experience, empower data modernization, enable digital transformation, and improve operational agility and enhance team collaboration. And this morning is going to touch on the data modernization and enabling transformation, digital transformation. So our data automation and visualization platform is Sisense combined with Safe Software FME. So Sisense is a market-leading, Gartner-rated visualization and business intelligence platform. It allows you to connect to any data. It can do this in 2 ways. It has its own data warehouse built into the application called the Elastic Cube or Elastic Cache. And also it has the ability to do live query into things like Snowflake and Redshift and BigQuery, but also into other relational databases, SQL Server, Oracle, and I'll show you this morning the application connecting to the PostgreSQL database in FME Cloud. From there, it can create AI-driven customized visualization and business intelligence experiences, both in a code-free and a code-first paradigm. And also from there, we can take action to infuse analytics everywhere, to create cloud apps, to integrate with communication platforms like Slack and Teams and Office 365, and to build workflows from your applications. And that's where we actually turn the story around and come back to FME so that we can actually do other workflows with FME once you've done your analytic. So there is a demonstration. I'm also going to go out to my site here, and I have on my page here, the Sisense application. So I can actually go in here and go to a very simple little dashboard that we've just created, which shows bed utilization, beds available in an area in a hospital. Now, it's all made up data, but this is sitting in FME Cloud. The data is sitting in FME Cloud in the PostgreSQL database, but I've got a simple dashboard here which I can connect to. So I can go to we've created a gallery app, and in that gallery app in FME Server, we can actually see that data that's stored in the FME Cloud. So very similar to what we have this morning. We have a little HTML report with all the hospitals and their addresses on the map. But also in our little gallery app, we have the ability to update the capacity against the hospital. So again, if we have a quick look at our dashboard, we can see Cork University Hospital has 500 beds available. So if I come out here to pick Cork University Hospital and hit, sorry, everyone talking at one time, hit the beds, and I put in, say, 800. So I'm now going to do this in my FME Server app, and I'm going to click the 800. So the FME Server app now writes that data to the database. It's made that change, and I go to my BI, and now I'm actually able to see that information. So if I refresh the page, it'll instantly take that information in. Not only is it taking it from the PostgreSQL database, but it's also bringing it in to the actual application, into the BI, into its own Elastic Cube. So straight away, we have straight insights. So we're not waiting for replication of data overnight. We're able to take it in live on the fly from the server app and see the dashboards updated as we do. Similar, this dashboard, we have a staffing application. So same idea. We can pick another hospital, say Cavan, fill information and say there's 600 staff employed in Cavan. And when we run the server app, that information is then being processed, is being pushed out into the database inside FME Server, but then being pulled live into the BI, so that the BI is automatically updated. And again, what we were talking about this morning is small changes and small updates and upserts. So with this live feed of a very modern platform like Sisense, where we can connect in, we can actually have data capture, so forms being updated using FME Server apps, but then the data coming through live into your BI, whether that's reporting on jobs being updated, reporting on status of information or whatever, you can then build your apps and show everything together. And if I just go back to our FME Server, you can see how this is really simply set up inside server apps. So we have our gallery app. So again, let's remember the kind of things that we can do. So inside the health gallery, we have our workbenches. We have them set up very simply. And we have our workspace apps. So we can see the capacity map is here. And we can see how it's set up and what job it does and what workbench it can run. And all really we had to do to create those forms in FME was create publish parameters in the desktop and the workbench, bring them up to the server app, and then enable them and show them in the app. And with this system, we didn't have to buy an additional database. We didn't have to stand up any other infrastructure. This has all been done with FME Server in the cloud, and all running in together. So really just shows you that with the tools today, there's no manual processes that you can't automate with FME. And I really think this capability for capturing information and pushing that data back in and then having it linked in to BI is where you're really seeing real digital transformation. So really quickly, because I always get the short straw and have to run through a slide in my presentation in 2 minutes, you can future-proof your organization with business automation. And I suppose the question for people is, are you ready to embark? Because again, that demonstration this morning did not show any maps, not showing any GIS. We are taking data, capturing the data. Server apps can run on phones, on tablets, now wherever they are, bring the data in and bring them into whatever visualization tool you want to be able to use. And I think, Garrett, that's just about me. If I stop sharing.
Thanks, Ciaran. I know that was a whirlwind of a presentation, and you and Gavin did work quite hard in the background to be able to show that kind of data capture piece and then being pushed out live.
We'll do a big webinar on that. I think that I think watch this space, and Gavin and I will do a more in-depth presentation where we'll show job management and work management being run through FME server apps and Sisense. So I'd say that'll be in the next few weeks. We'll do something on that, because it, as you said, it looks basic, but actually we've done some pretty cool stuff down there.
Yeah. Going on in the background. Brilliant. Thanks a million, Ciaran. So yeah, it's been an incredible day to say the least. So we've had an amazing lineup of speakers, and I just wanted to thank all of our presenters. So Don from Safe Software on the future of FME, it was a brilliant presentation. Also Philip Jacob from the Valuations Office, again another incredible presentation on how we start to automate that report creation, and I suppose the time savings has been incredible over that time period. Again, then we had Michael from Dublin Fire Brigade, again another great example of using FME Server and webhooks in order to be able to pull actionable intelligence out of a business intelligence platform. We had Ciara, who never disappoints, and another great presentation on how they are trying to automate that, I suppose, map product production, and again, just incredible scales of data going on in there, and again, but with a real enterprise vision in terms of having those business processes along the way to have a validated output on the other end for customers and staff and departments. Ardi from Safe Software, again up at 4:30. I think he flew to San Francisco, so fair play to him coming in, talk about scaling for the enterprise. And then again, Robyn, incredible presentation on the use of FME with inside National Broadband Ireland as part of that national fibre rollout. I'm really blown away by how much they've gotten done in such a short amount of time of using FME. So really impressive stuff there overall by our presenters. I only just kind of have one piece just to highlight, and again, we mentioned every year is, again, we have an IMGS, there's a regional group, so obviously there's the overarching FME community which you can join, and the knowledge base, and again, share ideas and get information and feedback from other users around the globe. But we also have a regional one, so a local group here in Ireland, where if you create a good workspace, you can put it up or you can share it with the community. We regularly put updates, so we put links out to webinars, any free workspaces, anything like that. So we regularly push stuff up there ourselves. So please go on and register. And again, we'll accept you into the group. So it'd be great to have you along. And then I guess just follow-up questions on our side. So I recognize they're a little bit over, but again, Gavin, I'm sure everybody has got Gavin's details at this stage, but if not, they're on screen. So again, if you have any questions about anything that we presented on today, please don't be afraid to reach out to Gavin, myself, Ciaran, or then Tanya again in the background. What we'll do is we'll collate the points that we had mentioned earlier on. So again, that's something Tanya and I will do, and then we'll probably reach out to you directly in order to get some sort of shipping details off you, and we'll send out that swag to the winners. And again, thank you so much for attending. Obviously, as our customers in the FME community, you make these events possible, and we would have liked to do a face-to-face one for this year, but it's just, I think, virtually just suit us a little bit more, and I think also the wider community as well. But hopefully next year we'll either go to a hybrid or a face-to-face version of it. So yes, thank you very much, and yeah, enjoy the rest of your days. Bye.
Thanks everyone. Enjoy.
Bye.
Bye.